Welcome back, everyone. Today's guest is Michael Duke, the CEO and founder of DBT Aero, which is revolutionizing aircraft with its double. I'm
Double
sorry.
box tail.
There you go. Yeah, there you go. There you go. You can go ahead and introduce yourself, Michael.
Yes, hello. Welcome. It's great to be here. Thank you for inviting me. My name is Michael Duke. I'm the founder of DBT Aero, which stands for Double Box Tail. It is a unique aircraft configuration, which we believe is the future of aviation. It's ultra efficient, safer by design, very stable and smooth in flight, and we believe it is easily manufacturable. So hopefully we will be seeing millions of these aircraft over the next 100 years, whatever. We believe this is the future of flight.
Awesome. DBT Aero is betting on aerodynamic efficiency over brute force propulsion upgrades. What was the insight that led you down that path?
Um, we had a very brilliant inventor who was looking at how to how to carry his family more affordably over long distances. And in order to do that, you needed smaller engines, less energy. So whether it's a combustion engine or an electric, hydrogen, hybrid, you need less energy, smaller propulsion systems, and just greater overall efficiency. So he spent many years looking at all of the research and finding that there were a number of physics principles that were not being used by current aircraft. And he had the brilliant idea of how you can integrate those multiple physics principles into a single airframe. And this is it, the double box tail.
Awesome. Can you talk about how laminar flow specifically influences range, fuel burn, and acoustic signature? Acoustic
Yeah,
signature.
natural laminar flow is one of those things that has been proven experimentally, but been much harder to get into production aircraft. Bugs, other, non-conformities, things end up messing up the flow. And so by doing some boundary layer control, we're able to maintain laminar flow much longer across the wing itself, also across the airframe. And that laminar flow means that you have less turbulence. Turbulence is you're using the energy for flight to make turbulence instead of to move the aircraft forward. So the goal of most aircraft is to streamline. It's just that there are certain things that you can't do a lot about. When you get to a wing tip, for example, the air flowing over and around the wing ends up flowing off those tips, and you end up with what are called wingtip vortices. And we saw those in the movie Top Gun Maverick, for example. The big dusty wingtip vortices. That's energy that's being turned into drag into those vortices rather than being used for flight. So the laminar flow is part of our design that reduces the amount of energy required, reduces the drag. And not only do we have laminar flow wings, but we also have laminar flow fuselage, and the other surfaces also are laminar flow. So we focus heavily on laminar flow.
When you look at new airframe concepts today, what criteria separates the designs that make it to certification from those that stall?
One of the criteria has to do with stability. And we actually have patents for stability and spin resistance. That's one of the things that is important in certification, both stability as well as the spin recovery, since our design inherently doesn't spin, we're able to get through that piece of the certification much more easily. Similarly, the safety measures, there's a number of safety stability that are part of certification. That's really what certification is all about, making sure the aircraft is safe, stable, easy to control, easy to recover. And those are things that are inherently built into our design, making the certification faster, simpler, less expensive.
Looking ahead 10 to 20 years, do you see the real disruption coming from new materials, new aerodynamics, or new propulsion?
Right now, most people are focused on new propulsion, and certainly that's a piece of it. If you look at the jet engine, the change in propulsion certainly was a catalyst for changing some airframe designs and truly revolutionized aviation in the 1950s and 60s. What we're seeing, though, is the propulsion is just one piece of it. The airframe itself is the piece that has not really improved. Um, in the 60s and 70s, we tried flying wings and blended wing bodies and a number of other designs. Sadly, they have benefits, but they also have some things that are not benefits, instability, etc. So we believe that this new airframe is a key to the new propulsion systems that are being developed. Now you make an airframe that is more efficient, more stable, along with these new propulsion systems, and together you end up with a multiplier effect. Now, both of those require new materials, and so that's one of the things that's important to making a new airframe like ours possible today are the new materials. This would not be possible with the materials from the 50s and 60s. So the advent of the composites and other materials, 3D printing, whether it's metal or composite, those sorts of techniques, as well as the materials themselves, are making innovations like ours and future propulsion systems possible.
When you go from prototype certification, scale production, what information flow becomes hardest to synchronize?
Um, I'm not really sure how to answer that. We haven't really thought about synchronizing the information flow, partly because our focus is moving to a digital twin. And as we move from, I guess, desktop engineering into a full digital twin, a lot of that information that's going to flow into the manufacturing is coming out of that digital twin system. So we're front loading that information flow in the digital twin so that it can flow more directly into the manufacturing system. So I hope that that streamlines the data flow and we don't end up with a lot of difficulties beyond that front loading of getting it into the digital twin.
If DBT Aero achieves its mission fully, how does everyday flight experiences feel different for the passenger 10 years from now?
Well, number one, the flights will be more stable. There's always turbulence in the air. We cut through the turbulence more smoothly. And so there's less turbulence, makes the passenger flight more enjoyable. The prices will be reduced since we're using less energy for flight. You can have lower costs per flight mile. And if I look at the rise of certain industries, such as back when I'm old enough to remember when the VHS tapes first came out, and the movie
Mm.
theaters were all concerned that they were going to go out of business because everybody would just do everything on VHS tapes. Well, it actually had the opposite effect. And I can't remember the actual official term, but there's a paradox that has to do with that. By making the distribution of movies cheaper, the distribution actually increased. And because of that increase, there was a need for more movie production. And the prices then continued to decrease. So instead of putting movie theaters and the Hollywood out of business, It actually grew the business. More people go to the movies now. There are more production companies, et cetera. As
Mm.
we believe that by making the aircraft a personal aircraft, a business aircraft, a commercial aircraft more efficient, more affordable, we will see air travel significantly increase. Back in the 70s, before deregulation, there were flights to a lot smaller towns than are available today. After deregulation, flights to those locations disappeared. We believe with a more efficient aircraft, flights will reappear in those smaller destinations, and there'll be less need to, as you will, flee the suburbs and go to the cities. And instead, you'll see people moving back to the suburbs and the rural areas where they have the air travel, the overnight air delivery, all of those sorts of things available, which went away because of the high cost and deregulation. This will come back just like we saw a growth of in the movie industry, a growth in automobiles as they became more efficient. We ended up with more automobiles, et cetera. So making aviation more efficient, we think will expand the market for everybody.
How do you ensure the distributed teams, design, testing, supply chain certification always share the same data context?
We have software that is sharing software.
Hmm.
Uh, I won't necessarily say which platform we use, but we have online data repositories. So we communicate certainly through traditional, phone calls, text messaging, online meetings, those sorts of things. But we also have data repositories in multiple types of systems that we can then share, comment, upload documents to, comment on those documents, revise them, etc. And so that's very important to keep the team all on the same page and informed when we can't always be on the same call because of time zones or travel or other things like that.
Okay. And to wrap this up, what kind of partners, collaborators, or ecosystem players do you think DBT Aero needs more to accelerate from the space forward?
We are actively reaching out to partners, and they are thankfully actually actively reaching out to us as well.
Mm.
We have not publicly announced who our partners are, except for one. And we announced a few weeks ago that Hexcel, the world's largest composites manufacturer, is supporting us as a partner. So we look forward to announcing in the coming weeks more of these partnerships. And those people are really critical as if you think about all of the parts that go into an aircraft, we certainly can't manufacture all of those ourselves. So the more partners that we have who can focus on their area of expertise, develop the parts of the aircraft that we need, and we're sure that they will be developing some unique parts which IP they will own. But as we develop more and more of these partnerships, we have a larger, if you will, virtual team, and all of these people are working together towards the same goal while they can focus on their areas of expertise and we focus on the integration and the overall vision.
All right. Well, everyone, this was Michael Duke, CEO and founder of DBT Aero.
Thank you
I'm gonna
very
go ahead.
much. I appreciate the opportunity to speak with everyone today and come visit us, see our brand new two-seat aircraft, which will be in customer hands within about 2 years. That website is DBT2LX. So it stands for our double box tail. It's a two-seat luxury model, dbt2lx.com, or you can go to our website at dbt.aero or visit us on LinkedIn or social media.
Awesome. All right. I'm gonna go ahead and end the recording.